The Vsauce hardware has been through a couple revisions, so I wanted to make a video to describe those revisions, talk about the decisions that were made along the way. Maybe even talk about some improvements that could be made in the future. So the initial project, I wanted to plug an Arduino Nano into an MPU so I could take over a solid-state pinball machine and reprogram it. The reason I chose the Nano, it was cheap and bulletproof, been around for a while, tons of knockoffs out there available. The problem is to control completely the MPU board, you would need 8 data lines, 13 address lines, and a handful of control signals. The Arduino Nano only really has 18 usable pins. Fortunately, on the MPU, all we really need to talk to is the PIA chips. And to do that, we can get away with a lot fewer address lines. So I still need to use the 8 data lines. I need to address the clock or read the clock. I need to read the IRQ line, control the read-write line and the VMA line. But we can trim the address lines down to just a few. For instance, if you want to talk to U10, you need A9 and A12 to be low. That means that we're not going to be talking out to, looking at the ROMs, that kind of stuff. So that's why A9 and A12 have to be low. We need A7 to be high. Both the PIA chips require A7 to be high to talk to them. And then for U10, you need A3 to be high, and then you use A0 and A1 as your register select lines. Now for U11, all that's true except for instead of A3 being high, A4 has to be high. In my initial implementation, the Arduino just plugged into those address lines. It grounded out A9 and A12 so that we could talk directly to the PIA chips without worry. And then everything else was just left floating because nothing was looking at those lines. The next question that came up is, can it run the old code? And the answer was no. We took out the 6800, so there was no chance of running the old code. But could the 6800 stay in? There was a halt line available on J5. The next revision of the board, I did all those things that I mentioned before, but instead of directly grounding A9 and A12, I ran them through a tri-state buffer. So I found a chip that had 4 tri-statable buffer lines, and if you flipped the switch so that we wanted to boot to the Arduino, instead of being tri-stated, those lines would be grounded, and that would ground out, actually I did 3 lines, that would ground out the halt line so that we would halt the 6800. It would ground out A9 and A12, and then the Arduino was free to do whatever it wanted to on the bus, because at that point, being halted, the 6800 would be tri-stated. So nothing was interfering with the Arduino. If you flip the switch the other direction, the machine was then dual bootable. So that's what I consider to be Rev 1 of the hardware. It uses a quad line buffer, and that chip is the 74LS 125. You need is that 125 and the Arduino Nano, and you can talk to the MPU and dual boot it. So a recap of where we're at with Rev 1. We're trying to talk to the U10 and U11 through J5. So we need a Nano. We're hooking that up through J5. We need all the data lines on there. And then for what I called Rev 0, we added the address lines so we could talk to the register select and chip select, the U10 and U11. We had to add some control lines in there so we could, fully communicate with the MPU. And then we had to do power and ground for the Arduino, and we have to ground out the lines that we want to be low. So in Rev 0, those were, grounded by hand. And that's why it couldn't be dual booted with the 6800. So for Rev 1, I added the 74-125, and that's the tri-state buffer, so that we could ground halt and A9 and A12 conditionally based on a switch. And so in the dual booting Rev 1 hardware, there's a switch where you can turn on that 125 and it grounds those lines, and then you have dual booting control. And then of course we have to have the the control lines, the data lines, the power and ground for the Arduino, and the register lines. What I call Rev 1A just adds in um, D13 into the mix because we weren't using D13 on the Nano. And that is driving line A5. And the reason is that the SB100 sound card needs to be chip selected with A5. And you can't put D13 directly on the bus from the Nano because on some Nanos that looks like it's pulling down to ground because there's a built-in LED on the board. So you have to buffer that. I had an extra line on the 74-125 tri-stated line, so I just ran D13 through that and hooked that up to A5. So Rev 1A is the same as Rev 1 except for it controls A5, which means it can talk to the SB100 Stern soundboard on some of the early machines with digital sound. So if you're running on any machine that doesn't have an SB300, that's all the hardware you need. This can talk to the 17, the 35, the MPU100, and the MPU200 as long as you don't care about talking to the SB300 sound card. It also works on Altec. It does not work on Weebly as far as I know. I haven't tried it. So that's where you can stop if you've got any of those machines and you're trying to port them, as long as you're not trying to talk to an SB300. And that's the next challenge, is to talk to the SB300. As you've seen in the previous diagrams, that's it. We're out of pins. And the SB300 needs a few more. So instead of having 2 register select lines, it needs 3 register select lines on A0, A1, A2. It also addresses on A5 and A6. So it needs a bunch more pins. And to get there, we have to add another component to the board and change out the quad buffer for an octal buffer. We need A3, A4, A5, and A6 to address U10, U11, and then A5 and A6 address the SB300. The good news is we only need one of those address lines at a time. A3 addresses U10, A4 addresses U11, and A5 and A6 address different parts of the SB300. In order to get that as efficiently as possible, we can demultiplex 2 of our address lines from the Nano and turn that into the 4 address lines A3 through A6. So we're going to do that with the 155, and then we have to put that through the buffer so that it can be tri-stated, so those lines from the 155 don't affect the bus when we're booting to the old code. So we upgraded our quad buffer to an octal buffer. We're using 4 of those lines to buffer the demultiplexed address lines that go to A3 through A6. We still need A9 and A12 to go through the buffer, so we can ground those. We still need to buffer our halt line, and that leaves us with 1 extra buffer line, and we need that so we can tie A7 high, so we can continue to address U10 and U11. So that uses all the lines on our octal buffer, and we're using the demultiplexer to turn 2 address lines into 4 address lines, and that gives us the ability to control both the MPU and the SB300 now with the Arduino and then 2 other ICs. I'll be upgrading my Meteor 2021 code to use the SB300 as an alternative to the wave trigger in case people don't want to upgrade their sound hardware too. If you're doing a port or a recode of a machine that has an SB300, I would recommend hardware Rev 2 obviously, so you can have access to that, all the hardware. Otherwise, Rev 1's fine. I'm going to post my schematics and some Gerber files that I've made to create the board, and I assume I think RoyGBev on Pinside is going to be doing another kit for Rev 2 for SB300 people in the future. I'll do a video on the SB300 describing its capabilities and showing how to code that for the Arduino sometime in the future as well. If you're still watching this, I hope you got something out of it. I wanted to put all this in one place because these questions have come up as to how and why I've allocated the pins of the Arduino Nano. So I wanted to document that in a way that was not just dry text, kind of showing you the lines and explaining, how they got to where they are. So I hope it was informative and not deadly boring, but whatever, who cares? Until next time. I hope you build this, and I hope when you do, you send me video. There's plenty of people who have built their machines, and then for whatever reason they don't post video of it, and I just want to see the videos. So I hope you post videos. Thanks.